Hello everyone, welcome to Engineering and Automation YouTube channel. Today we are going to learn about the basics of Building Management System (BMS). This will be a series of videos where we will be explaining all about the Building Management System. So please subscribe and stay tuned. What is a BMS system? Let's take this high-rise building for an example. This building will have many mechanical, electrical and plumbing equipments. Mechanical equipment such as chiller, chilled water pumps, water heaters, ventilation systems such as air handling unit, fans, etc. Electrical equipment such as escalators, lighting, electrical panels, etc. These equipments will work standalone without any coordinated functionality. For example, to provide comfort in the building, the chiller should be delivering the temperature at a certain degree Celsius. Without a coordinated system, it is very difficult to manage all the equipments manually. This is where the BMS comes into action. BMS connects all these equipments in a centralized manner. BMS controls, monitors, and optimizes these MVP equipments using hardware and software components. It is a package of intelligent microprocessor-based controllers which connects directly to these equipments at field level. The controller sends the data to a management system where the data taken from the field equipments are translated into a graphical user interface format. BMS provide comfort to the building occupants, energy savings to the client, easier troubleshooting opportunities to the building operator. The BMS system comprises of three main levels. First one is the field level. This level refers to sensors, instruments, valves, actuator, thermostat, IO modules, etc. This level plays an important role in the building management system, as the action taken by the BMS system is purely based on the inputs received from this level. Next is the automation level. This can be called as the brain of the building management system. It consists of compact and modular DDC controllers. The DDCs process the inputs from the field devices and takes action to provide comfort to the building occupants and safety and security to the building equipments. The DDCs are freely programmable. The controllers can be connected to a handheld operator terminal to control or monitor the field equipments at the field level without the requirement of any management system. Next is the management level. The management level provides an interactive user interface to the building operator. It displays all the information taken from the field level by the controllers in a graphical user interface format. The management level can either be a PC or an HMI, human machine interface. The management level can also send data via text or email message in case of any critical alarms. The field level sensors and devices are connected to the automation level via hardware connections, typically with a single pair cables. The operator terminal can be connected either via a bus cable or a standard Ethernet cable. The automation level is connected to the management level via BACnet IP protocol with the use of building structural cabling networks. Let's look into the communication protocol being used in the BMS system. The most commonly used protocol is BACnet protocol. It is a building automation control network protocol developed and managed by ASHRAE. It is an open protocol for the BMS system, but different BMS systems can be integrated. Next widely used protocol is LonPop, local operating network. It is widely used in low bandwidth applications. Next is the Modbus. It is a serial communication protocol which uses master-slave technology. This is a very old protocol which is being used in the PLCs from 1979. Most commonly used communication protocols are BACnet via Ethernet IP, BACnet via LAN, BACnet via MSTP, Modbus via RS485, Modbus via RS232, Modbus via TCP/IP. BMS has many features, which makes it as an important system in the building comfort and safety applications. Let's see some of the features here. First one is the graphical user interface. All the BMS system provides a graphical user interface which represents a 2D or 3D view of the equipments. It also displays the sensors installed in the equipment. Next, the most important feature of BMS is alarm management functionality. BMS system provides a variety of alarm management functions, such as the alarms can be grouped on the basis of priority. For example, fire alarm is treated as top priority, whereas the dirty filter alarm is treated as normal priority. It is also possible for the BMS system to send the alarm information to an external program such as maintenance management software to generate work orders based on alarm descriptions. In order to identify if the equipments are performing efficiently, BMS provides a trend management functionality. It displays raw value in a time-based graph. These graphs can be exported into an Excel format for analysis. Since the BMS system is also referred to as an energy management system, it provides a functionality to control the equipment based on time, known as a time scheduler. The time scheduler lets the operator to decide when to turn on and turn off the equipment. The A2 serving to the office can be programmed to turn on only during the work hours from 7 a.m. to 6 p.m. and after 6 p.m. till the next day 7 a.m. the equipment will be turned off to save energy. This is very helpful in many cases where the equipment can be configured to turn off when there is no occupancy in the building. Let's get to know about the history of BMS a little bit. In the 1880s, Baron Johnson, founder of Johnson Controls, patented the electric thermoscope, now known as the thermostat. It is a bimetal coil with mercury switch, which is used to alert the fireman to open or close the heating damper. Later, Baron Johnson developed his thermostat to a multi-zone temperature control system using pneumatic controls. The pneumatic control uses compressed air to open close pneumatic control valves or open close air dampers. It is widely used in the building controls to 1960s. From the 1970s, pneumatic controls were replaced by electric controls, and the building controls evolved into building automation controls. Building automation control uses BDCs, direct digital controllers, with relays to control the HVAC equipment. In today's world, the building management system is not only used in HVAC applications, but also used to integrate various building systems into one. BMS plays an important role in smart cities and building energy efficiencies. It also saves operation cost to the building owner. BMS has many advantages. Some of the advantages are found here. First one is lower operation and maintenance cost. With automated functionality, BMS provides lower operation and maintenance cost to the building owner. Next one is increased comfort and efficiency of equipments. With the ability to fine-tune the system, BMS increases comfort to building occupants. Also, the efficiency of the equipment increases. It also improves building security and equipment safety. With the ability to alert immediately in case of any abnormalities, BMS improves equipment safety and building security. With its ability to transfer data to a maintenance management system, BMS increases staff productivity and performance. These are the basics of the BMS system. Now, in the construction industry across the world, building management system is also referred as iBMS, BAS, BACS, EMS, etc. iBMS, Integrated Building Management System. When multiple third-party systems such as fire alarm, access control, lighting control, parking management system, etc. are integrated with the building management system, it is referred to an integrated building management system. This allows the building operator to have centralized control of all systems from one place. Next is the BAS, Building Automation System. This is a standalone system without any management functionality, typically with a DDC control panel and handheld operating terminal. Next is BACS, Building Automation Control System. This is similar to a building management system, but in some cases PSC controllers are used with SCADA system. Also in some cases BACS also controls fire and life safety equipment. Last is the EMS, the Energy Management System. When additional energy management functions are used in the BMS system, it is referred to an energy management system. Such kind of features are used in the green building applications. I hope you liked the video. If you have any suggestions or comments, please leave it in the comment box. Also, please subscribe for more videos like this. Thank you.